last part of day 4 is how do we solve a quadratic. Common way a lot of people use is solve by factoring. So I'm going to write factor x method. That's a very common way we did last fall. You could have what's called a greatest common factor, solve that way. You can solve by square rooting. Sometimes that's a great option. Another option is completing the square, which we're not going to go over that one today because it's not very commonly used. So the other one we're going to talk about is quadratic formula. Alright, so looking at this, the x method, if you have 3 terms, you set it equal to 0, and then we do what's called the x method. You identify A, B, and C. So on the top of the x is A times the C, and on the bottom is your B. In this case, remember these are 1s, so 1 times negative 20 is negative 20. And we have a negative 1 for our B term. To do that, we're trying to find the factors of 20 that can add up to 1, basically. It can include positives and negatives. So over on the side, I'm going to write the factors of 20, and I just list them as pairs, like 1 times 20, 2 times 10, 4 times 5. So in this case, I would use 4 and 5 to come out to a negative 1. In order to do that, we need a positive 4 and a negative 5. Again, we talked about factoring in the fall. This is just reviewing how to factor something. You replace the middle term if you use the x method with what's in the middle. So I have plus 4x minus 5x minus 20. Then we do what's called grouping. We're going to group the first 2 together and group the second 2 together and take out what's called their GCFs. So this first parenthesis, both have an x. So I'll do x plus 4. What's left. These, you bring down the sign here. If this is a minus, we're going to take out a negative 5 here. When you divide 2 negatives, this comes out to x and a positive 4. These 2 parentheses need to be the same, or we took out a GCF wrong. The first parenthesis is made up of what GCF did you take out, and the second parenthesis is the one that you can see they have in common. To solve, you set each of your parentheses equal to 0. These are now one-step equations, like to solve for x. How do you do the opposite of minus 5? You would add 5 to the other side. This one, the opposite of plus 4 is to subtract 4. 0 minus 4 equals negative 4. So those are our factors. I'm going to go back up to the above example that was on the other video. When you have x squared minus 4x minus 5, and I want the factors of negative 5 that are going to add up to negative 4, the numbers I was going to use in this case earlier would have been negative 5 times a positive 1. And you know, we talked about sometimes you can shortcut these when it's just an x squared. So like x minus 5 and x plus 1 would be considered like our factors of that. Because we want to set it equal to 0 to find the roots for the zeros, that is, if you look over here, x minus 5 equals 0. Well, if you add 5, that's why one of the roots was 5. If you do x plus 1 equals 0, you would subtract 1. So that would leave me with x equals negative 1. Now we just used the graphing calculator on that example to find the roots by just graphing that. But you can also factor that and set the parenthesis equal to 0. So that's another way to find roots. Alright, this one isn't set equal to 0. So the first thing we want to do is subtract the 27 over. So the last one we could have kind of shortcut plus 4 minus 5. Look at my parentheses, plus 4 minus 5. We can't do that shortcut on this one because we have a number here by the a. So when you go over here and you take your a times your c, that's going to give you negative 54 and 15. Let's see if we can come up with a pair that comes out to work out. 54 divided by 2 is 27. So, like if I made a list, well, 2 and 27 are too far apart. So I'm going to try another one. Let's try like 54 divided by 3. That's 3 and 18. Since this is negative, that would actually work. To make that work, we would want to have, looks like a positive 15, so we want a negative 3 and a positive 18. Those multiply to negative 54, and they would add up to 15. Okay, so you replace the middle term, and you put those numbers over here. Once you replace the middle term, the b term, those are in the middle, you're going to group the first two and group the second two and take out their greatest common factor. These can both be divided by an x, so you would be left with 2x and minus 3. Bring down your plus sign. 18 and 27 can both be divided by 9. See, is that the biggest one though? So 18 divided by 9 is 2. 27 divided by 9 is 3. And I know that's correct because if you look at the two parentheses, they matched up. So we have x plus 9 and 2x minus 3. You now set each of those equal to 0 in order to solve. So if you subtract 9 to the other side, you're going to get x equals negative 9. 2x minus 3 equals 0. You would have to add 3 and get 2x equals 3. Divide by 2. This one's a little bit more complicated. I get x equals like 1.5, or you can leave it 3 over 2, or you make it 1.5. However you want to write that fraction or decimal, that's fine. But those would be the zeros. If I was going to graph it, I would probably say it's like 1.5 because that's easier to graph than 3 over 2. So, just depends what you're doing with your answers. Alright, this next one, we can do the x method, but 36 times 121 is 4,356, and that is a really big number. So let's look at these numbers. This one is called a special case. It's called difference of squares, because both the number 36 and 121 are called perfect squares. The word difference comes because it's a subtraction sign, squares, because both of these numbers can be square rooted. So what we're going to do is we're going to square root both of these numbers. The square root of 36 is 6. So in the first part of the parentheses, we're going to put 6a and 6a. Because 6a times 6a gives us 36a squared. To get 121, the square root of 121 is 11. So we're going to put plus 11 and minus 11. Because we need these two numbers to multiply to a negative 121. So positive 11 times negative 11 gives us the negative 121. And if you want to see why there's nothing in the middle, if I was going to work this out over on the side, I don't want to mess with this because this is like my answer, but if you FOILed this or multiplied, distributed this back out, and you did like the outside, you would get negative 66a. The inside, you would get plus 66a. And you notice those ones in the middle are exactly the same. They actually cancel each other out, which is why, if you look over here, there's no a term, there's no middle term to this problem. So that's why this one's unique. We can square root the first number and split it up into 6a and 6a. Square root the second number and get 11 and 11, and that's just a quicker way to do this, we still have to solve because it says equals 0. So if you were going to set this equal to 0, we have 6a plus 11 equals 0. So you'd minus 11 and then divide by 6. And I just wrote it as 11/6. If you do the other one, equals 0, you would plus 11 over, so you get a positive. So how is square rooting coming into play? How could that be an option? Difference of squares is one way to do this. Another way to do this question, which I didn't leave myself very much room, is to take 36a squared, add the 121 to the other side, see that, then divide by 36, and you have this fraction. A squared equals 121 over 36. Well, anytime you have a squared, you can square root that problem. So you can either square root it here and then solve for them, or if you get the a squared term by itself and then square root of 121 is 11, the square root of 36 is 6. You just don't want to forget to put this little plus and minus sign to show that technically both of those answers work. A positive, you can see them here, I have them. If you solve them individually, you get a negative 11 over 6 and you get a positive 11 over 6. Or when you do the square root way, you just have to remember to put positive and negative 11 over 6. So this is called solve by square rooting. This is like X method or solve by difference of squares. Alright, the last one is what seems to be most familiar to my people coming in from middle school, is solving the quadratic formula. This has a equals 1, b equals 6, c equals 4. It does have to be set equal to 0 to start with. So we're going to plug these numbers into the quadratic formula. I'm sure most of you guys remember the song. X equals opposite of 6, that's a negative b, so opposite of 6 is negative 6 plus and minus the square root of b squared, so we have in parentheses 6 squared, minus 4ac, a is 1, c is 4, all over 2a. If you knew the Pop Goes the Weasel song. There's lots of versions, but that's the most common one. You can really put everything that you see in here in your calculator, so I'm going to do 6 squared minus 4 times 1 times 4. So I get x equals negative 6 plus and minus the square root of, that comes out to 20. Now on bottom, 2 times 1 is just 2. Let's go ahead and, I think in algebra 2 you would simplify that square root of 20, break it down to like 4 and 5. But for EOC purposes, I'm going to let you just get a decimal, I think. So the square root of 20 is about 4.5. So this is one way you might see this. Negative 6 plus 4.5 divided by 2. And negative 6 minus 4.5 divided by 2. One answer is negative 0.75. These are our x-intercepts. As you can see, they would be not really fun to graph. We use quadratic formula when you can't factor something, so that's why you get these kind of weird answers. So if you can't factor something, quadratic formula is a good thing to go by. If you ever see answers that look like this, like let's say I have to break down 20 to 4 times 5, and you get an answer of 2 square root of 5. Basically, you may see answers that look like this, and they might reduce all those by 2. So if you divide negative 6, you get negative 3. 2 divided by 2 is just 1. So I'm not sure how you're going to see it on the EOC when you do the quadratic formula, if they're going to leave it in what we call radical form. like leaving it with a square root in it, or if it's going to round to a decimal like that. A lot of times if they're graphing things, they like to round them to decimals. Sometimes they just want you to find an answer, they'll leave it like this. So either answer is kind of acceptable, but depends on the situation how you might see them work it out. But that is the quadratic formula, and you use the quadratic formula to solve a quadratic that cannot be factored.